Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on boiling point elevation, which is a colligative property. In our last lesson, we learned about a different colligative property, vapor pressure lowering. We learned how to calculate the vapor pressure of a solvent after a certain amount of solute is added. We also learned how to explain the change in vapor pressure of a solvent when a certain solute is added. In this lesson, we will learn how to calculate the boiling point of a solution after a certain amount of solute is added. We will also learn how to explain the change in boiling point of a solvent when a certain amount of solute is added. Students, if you are ready, we will get started. We have learned that the boiling point of a liquid is the temperature at which a liquid's vapor pressure equals the atmospheric pressure. However, the boiling point will increase if a non-volatile solute is added to a solvent. This is because the vapor pressure of a solvent at a given temperature is lowered by the presence of a non-volatile solute. Fewer solvent molecules are available on the surface, and thus fewer are exposed to atmosphere in the presence of solute molecules. Therefore, this type of solution has to be heated to a higher temperature than the pure solvent in order for its vapor pressure to be equal to the atmospheric pressure. The boiling point elevation is defined as the boiling point of the solution minus the boiling point of the pure solvent. The elevation in boiling point is directly proportional to the molality of the solution, which is shown in this equation. The small m represents the molality of the solution, and the Kb is the molal boiling point elevation constant for the solvent. This table shows the boiling points, molal boiling point elevation constants, freezing points, and molal freezing point depression constants of some solvents at a standard atmospheric pressure of 1. Students, before we continue on with our lesson, let us do an activity to review what we have just learned. In a moment, you will see a number of statements. Please decide whether each statement is true or false. If it is false, explain why.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. Were you able to tell which statements are true and which are false? Let us go through them now. The first statement is false. The boiling point is the temperature at which a liquid's vapor pressure equals the atmospheric pressure. The second statement is true. The third statement is false. The elevation in boiling point is not directly proportional to the color of the solution. It is directly proportional to the molality. Let us continue by learning how to calculate the boiling point of a solution when a certain amount of solute is added. We will calculate the boiling point of a 0.33 molal solution of a solute in benzene. If you remember from the chart we looked at, the molal boiling point elevation constant of benzene is 2.53 degrees Celsius per molal. We can use the information we know in the equation we looked at previously. Thus, the change, or elevation in boiling point, is equal to the molal boiling point elevation constant of benzene multiplied by the molality of the solution. The answer is 0.83 degrees Celsius. We can use this number to determine the boiling point of the solution. The boiling point of the solution is equal to the boiling point of pure solvent benzene plus the change in the boiling point. This gives us the answer 80.93 degrees Celsius. Students, now that we have gone through this process together, you are able to try it on your own. Please calculate the boiling point of a solution that contains 200 grams of sucrose in 500 grams of water. The molar mass of sucrose is 342 grams per mole. Also, note that the molal boiling point elevation constant of water is 0.512 degrees Celsius per molal.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. I enjoy doing these calculations, and I hope you do too. Let us go through the steps together. We were provided with masses of the solute and the solvent, as well as the molar mass of sucrose. We can use this information to determine the molality of the solution. 200 grams divided by 342 grams per mole times 0.5 kilograms equals 1.17 molal. We can use this number in our original equation. Therefore, the elevation in boiling point of the water is 0.512 degrees Celsius per molal multiplied by 1.17 molal. The answer is 0.6 degrees Celsius. In order to calculate the boiling point, we simply have to add the boiling point of water, which is 100 degrees Celsius, to the elevation in boiling point, which gives us the final answer of 100.6 degrees Celsius. Today, we learned about the change in boiling point that occurs in a solution when certain solutes are added. We also learned how to calculate the boiling point of a solvent after certain solutes have been added. This is all for today. Until next time, thank you, teacher. Thank you, students.